Regression analysis builds on the idea of correlations. It's used to understand how combinations of variables are related to another variable rather than just how two variables are related to one another. So for instance, we might want to try to predict how many birds visitors to Kiwiland see, and we already know based on our previous analysis that that's correlated with the length of their visit. But maybe we think that we could predict even better if we also take into account how far they walk, because we know that different birds spend time in different parts of the island. So if you don't walk far enough, you might not even have a chance to see certain types of birds. The variable that we're trying to predict in that example or any other is called the dependent variable. So in this particular example, the dependent variable is the number of birds seen. The variables that we're using to make the prediction are called independent variables. Other words that you sometimes might hear are predictors, drivers, or features. But they're all the things that we're trying to use to determine what influences the dependent variable. So in our example, the independent variables are length of stay in hours and the distance walked in kilometers. When there's only one independent variable, regression analysis is going to give us the exact same conclusion as correlation. So in other words, if they are correlated, and we've already seen that through correlation analysis, we'll also confirm that through regression analysis. The only difference is the regression output is more useful for making predictions. With a correlation analysis, we can sort of intuitively look and see what we're going to expect for a particular value, but regression gives us the exact information to make that prediction very precisely. Regression works the same way with more independent variables, so we can go 2, 3, 4, 27, even more. But obviously it's harder to visualize beyond one or two independent variables, which is why our focus here has been on the smaller numbers of variables.